All right, well, good morning, everybody. I think we're ready to get started here. So let's, for the benefit of the folks on the phone, let's just quickly go ahead and we can do a round of introductions and then we can jump right into it. So this is John Yarbrough with DWR.
Ted Craddock with DWR.
Matt Mintick, Citizen Ad Hoc.
Bill Connolly, Duke County Supervisor.
Eddie Andrews, member of the IRB.
Sean Early, Ad Hoc Water Supply.
Genoa Widener, Ad Hoc Recreation.
Curtis Grima, Assemblyman Gallagher's office.
Rob Olmsted, Senator Nielsen's office.
And James Gallagher, Assemblyman.
Les Harder with HCR.
Rhonda Ronalds, HDR.
Steve Berrigan, consultant on the CNA. Eric C., DWR Oroville.
Dave Duvall, DWR.
Dan Wade, IRB.
Andy Bendar, Oroville Division.
Matt Murray, Oroville Field Division. Sergio Escobar, DWR.
Steve Sarkisian, DWR.
Nick Rubeck, Council.
Liza Whitmore, DWR.
Well, thank you everyone for joining us. This is our sixth meeting here at the Ad Hoc Group. And so as we basically jump right into it, I want to start off, want to hand over to Ted Craddock, who's going to make a couple opening statements, and then we can see if there's any other opening comments, then we can get to the IRB's report.
Yeah, I think we just wanted to, again, thank the Assembly, then Senator's office, and the members of the Ad Hoc Group for being involved in this process with us. I think just maybe to recap, what we're doing is engineering planning study as part of the comprehensive needs assessment. And it really includes a comprehensive look at the facilities. And as part of that comprehensive review, we're identifying areas of potential vulnerabilities of the facilities and then measures for possible enhancement. And that's really what we'll be talking about today. And so that information is used, as Sergio will be talking about, to take that information, put it on a standardized risk scoring type process, and then allow us to really help prioritize and rank these different measures. So today we'll really be talking about the measures and kind of what led into those measures. Moving forward, we'll be then taking that information and sharing at future meetings how those measures can be put into potential plans for consideration with an outcome towards the middle of next year of a report with recommendations for consideration moving forward. One for further study and then possible implementation. We'll be taking that information and using it in the context of the broader state water project. So we're also conducting a similar review of other facilities throughout the state water project. And so we'll be looking at how these things fit and rank versus throughout the state water project as well. We're really looking forward to sharing. We've spent a lot of time actually thinking about how we can share as much information as possible today, but also, with the need to try to balance sharing a lot of detailed information that from a public safety and homeland security standpoint. So I think we're really trying to share as much today as possible, but do have to think about what level of detail can be put out in the public from a homeland security perspective. So in advance of the meeting, we did meet with the CHP, the Sheriff's Office, and other law enforcement partners to share the details of the study, and then additionally with the independent review board. So there'd at least be some other parties with context of the detailed work that's been done. So that's where we're currently at, and I think look forward to jumping into it and sharing where we're at and having a good discussion today on the different measures we're looking at.
Well, thank you. I don't know, Assemblyman, do you have any opening thoughts here?
Well, again, thank you everyone for being here this morning. Looking forward to getting down into the weeds a little bit more on some of these measures. I think we also as we've said earlier, we're looking to getting into the meat of, hey, what are some measures that could truly improve the safety and reliability of the dam, and so in the dam complex, and so just looking forward to getting that discussion and just getting some more information, as to what's been ruled in, but also maybe what's been ruled out. Maybe some more specifics on that. And so anyways, just looking forward to the discussion and being able to give you some feedback on what's been done thus far. So.
All right, well, thank you. And
I'm going to defer to the assembly member on opening comments.
all right. Well, with that, first up on our agenda, we have the IRB report. And so, Dan, I will turn it over. Betty, I will turn it over to you. Yeah, that's right. So.
In the seat. Good morning. Betty Andrews, member of the IRB. Bruce Muller, who is on the telephone, the chair of our board, put together this presentation with some of the salient aspects of our report. We have only 20 minutes, so I'm going to move a little bit quickly through this morning. I know we've got a lot of time for discussion later. The outset, I wanted to remind everyone of the members of the IRB, myself, Betty Andrews, Dr. Lelio Mejia, Bruce Muller, Paul Schweiger, and Daniel Wade. And Dan is in the room with us today as well, in addition to Bruce on the phone. We have been keeping a comment log, as you're aware, that captures each of the recommendations that the IRB has made in each of our reports. And at the conclusion of every meeting, we review that comment log and identify what the current status is on each of those comments. And we have 6 different categories that we use to classify those comments that range from under consideration, planned, in progress, to closed, not adopted, or superseded. And so each comment is placed into one of those 6 categories. At this point, what you can see from the table that's visible on the screen is that the comments that were made in the earlier meetings, by and large, are either in progress or closed. When you look at the totals, you can see that by far the majority of the comments, the recommendations that we have made, land in those 2 categories. We have a couple that are still under consideration. Some planned that we won't be able to see until we see final work products, and one that was superseded by a subsequent comment. So very much seeing the effect of those recommendations on the process as reported to us. The first question that we were asked at the end of the meeting, and I will say the meeting that was held was one of the densest meetings that I have ever participated in terms of the amount of material presented and the backup for that. And as a result, our IRB report references a lot of things that you don't have the benefit of having seen those presentations. But these are the comments that we made in response to the questions posed. Studies on schedule. The existing condition assessments are completed. 327 potential failure modes were considered. 125 of those potential failure modes were fully developed into 411 different scenarios, and a total of 2,055 risk scores were calculated. The 2 consequence areas that received special scrutiny were likelihood and life safety. Those were compared where they overlapped with the FERC Part 12D semi-quantitative risk analysis, and they compared quite favorably. Overall, the IRB is very happy with the approach that's being taken in this risk assessment and pleased with the progress being made. We were provided with a draft copy of the report for task number 3 and asked if we had any recommendations or comments on what we heard about the progress on those task reports or what we saw in that sample report. We had a few suggestions about how to make the reports more useful, making sure that the full task name is in the title, using a lot of graphics and call-out boxes to break up that very dense material, some specific display recommendations for risk categorization. There, in the risk management table, there are large red fields and large green fields. In the upper right and lower left quadrant, we thought it would be helpful to subdivide those further to indicate the relative degree of risk within those areas. We suggested that special care be taken to make sure that the definitions of resiliency components are consistent with common definitions, such as those used by the Corps. And we suggested that there be a graphical display developed that would show relative risk contributions of all of the PFMs estimated for each task in a single chart as a way to be able to look comparatively at those risks. The third question asked was, in response to a presentation that we saw on the emergency spillway erosion analysis that was done, and we were asked for comments on that. We noted that the erosion analysis that was conducted for the area downstream of the secant pile cutoff wall used flows between 6,000 CFS and 421,000 CFS. It assembled the current knowledge of the geology of the area, used an approach developed by Annandale in 1995 to estimate erosion based on stream power, and made modeling assumptions that were appropriate for the level of a planning study. And what we saw was that when 2017 conditions were run through that model, there was a reasonably good correlation between the results of the model and the estimated events in 2017, which gave good cause for confidence in using it as a planning level model and assessment tool. The IRB was then asked if we had any recommendations or comments on the updates for tasks for which we saw a presentation, tasks 1, 3, 4, and 5. We began with a few general comments. We noted that the documentation of the potential failure modes had been well prepared, that there was also an inconsistency in how intervention was treated in the potential failure modes. It appeared that in some cases, intervention and the possibility of failed intervention had been accounted for explicitly in the event tree, but it had not been used in every case. And we noted that there were probably additional instances where intervention could make a difference in the progression of that event tree. And by failing to include those, we may have conservatively overestimated the risk for that potential failure mode. So we recommended that emergency intervention be addressed in each of the potential failure modes that was developed and considered. We saw a presentation on task 1, which addresses the emergency spillway. In that for that task, there were 2 PFMs that were carried forward for developing mitigation measures. One was erosion of hillside materials, creating tailwater impacts on the Hyatt power plant. The second was scour downstream of the secant pile cutoff, leading to undermining of the secant pile wall, apron, and concrete monoliths. There were a total of 50 conceptual measures considered to address those potential failure modes, and 9 measures that survived the consolidation and screening process to become recommended measures recommended for further consideration. Task 3 is associated with the FCO headworks and main spillway. The risks there indicate that the long-term performance of the gate support system is a leading risk or concern, and yet no measures were proposed to address this situation. The IRB encouraged DWR to use the CNA study to document a proactive approach to researching and thereby addressing this issue. Question number 4. Still on question number 4, now for task 4, which relates to the low-level outlet. There were 33 PFMs that were developed with primary risks identified in the rock anchors of the Hyatt power plant and slope instability above the Palermo tunnel unit, the Hyatt switchyard, the area control center building, and the Hyatt access portal. There were a total of 57 potential mitigation measures considered. Out of that consolidation and screening came 5 recommended measures. The IRB had a recommended measure that we didn't see among those that were advanced, and that was consideration of a dual-purpose single low-level outlet rather than only looking at combinations of low and high level or low level that was single purpose. Task 5 addressed embankments. The IRB suggested that the team provide additional information, thank you, for the process used to identify the selected PFMs that were of the highest risk. Simply had a question about how that was presented. And then question number 5, does the IRB have any other recommendations or comments? We recommended that for the supporting analyses done for each of these task reports that they receive peer review. We also suggested that wildfire be considered as a possible initiator of failure mode, and that gets some discussion in each of the appropriate facility areas. We also suggested that in considering or in presenting the need for an additional low-level outlet, that 2 purposes be recognized for that. One is the ability to substantially lower the reservoir in the event if a failure mode begins to develop as a result of that high reservoir level. And then secondly, the availability of that low-level outlet to reliably perform its function when needed. The closing question was simply a request for any other recommendations or comments. The IRB recommended that the department frame the study outcomes and recommended plans around both safety improvement and risk reduction. And those are 2 sides of the same coin, but they are heard differently by different people, and we think it's helpful to have each approach used in the presentation of results. Secondly, we recommended, as mentioned before, that there be consideration of subdividing the red higher risk zone area into 2 zones, so you recognize areas of lesser and greater risk within that red zone. And that was a summary of our memorandum that you've all had a chance to read as well. John, do you want to have discussion now or get through the project status report?
I think if there are any questions now, I think it would make sense if anybody has any questions to ask them, but we'll have more discussion later as well. But
Yeah.
I don't want to cut anything off.
I had a few, but does anybody else have questions right now on the IRB report? Okay. One thing that just came to my mind was you guys noted that intervention wasn't consistently used in PFMs. Is that right?
in evaluating how a failure would progress. Yes,
Right.
there are opportunities sometimes to intervene.
What it triggered for me was, and I think you noted that when it comes to the emergency spillway, I think when water's already flowing over the top of the emergency spillway, there's not a lot of intervention that you could do, right? However, during the event, as I recall, knowing that we could be getting to emergency spillway, there was intervention that was done, including doing some grouting work, kind of there at the corner, rocking and grouting. We ended up taking down a bunch of vegetation to kind of prepare that. And then it also triggered for me, I think a couple meetings ago, we talked about revegetating that area. And I thought, do we really want to do that? And I'm talking specifically about the emergency spillway. Because it takes a lot of, there was a lot of work that went into kind of prepping up that emergency spillway, and then we know what happened afterwards. When you're thinking about possible interventions, or maybe not having to do as much intervention so that the structure can work according to its purpose, and maybe this isn't just a question for you, but it's just maybe more broadly, we do some intervention, and we did do some intervention with regard to the emergency spillway prior to it going into use. And as we look forward, is that something that's being considered or discussed at all?
So as we look forward at the, I can start with like the replanting there, part of this, we're looking at where you would do replanting. Part of that is looking at eventually if these structures were used, right, don't plant trees right downstream of the emergency spillway. So I'd say the replanting isn't proposing to do that. So that's sort of one topic there was with that specific structure, what are we doing going forward?
That's being looked at in terms of those are being planted in areas where it wouldn't be in the middle of the flow.
Right.
Okay.
So that's for that one. I think in this study, the comment was in some places, these failure modes, what wasn't considered is are there actions that you could take as it's,
right.
and if you did those actions, what that would do is that would show up on the when we plot things on this chart, the risk matrix, it would either reduce the risk or reduce the likelihood of the failure progressing all the way through. So I think as I understood the feedback is we have maybe overstated the risk in some cases because we didn't take into account these things you could do while a failure was occurring.
Right. Okay. With regard to the IRB's comment on the low-level outlet, I agree with that 100%. But in the report, it says that the team seems to be challenged to connect the notion of a low-level outlet to a specific failure mode. And that seems totally counterintuitive to me. Because to me, that's been one of the major problems at Oroville Dam is when we get a lot of water all at once, usually in when you have a Pineapple Express rain on snow type event, that seems to be the main issue, man, is we get too much water at once, and it's either going to, we're going to send a big surge through the FCO, or in the 2017 event, we had to go to emergency spillway. It's having a low-level outlet to de-water the dam more in advance of maybe such an event. And as we get better at forecasting, potentially, it would seem to me that connects to a lot of different potential failure modes and really the potential failure modes that we've actually experienced. Would anybody disagree with that? And if so, like why? Is my question.
Dan, would you like to speak to that?
If I may, Barry, we agree. I think the comment originates from the fact that the way the CNA has been structured, there are specific tasks, and there's discrete areas of concentration within each task. And so if you isolate a task and look for measures that go directly to PFMs associated with that task, the the low-level outlet doesn't necessarily make a direct connection in some cases to the PFMs that are considered. And so the comment essentially makes the point that the low-level outlet actually has a very positive influence in risk reduction when you take the structure holistically, as you're pointing out.
Isn't the low-level outlet one of the tasks?
Yes, it is.
Right.
But the task in isolation, when you consider PFMs that are related to that directly, there are the benefits of having the low-level outlet doesn't necessarily go directly to some of those PFMs.
So, I mean, so what a PFM might be overtopping, right?
Which is the embankment, which is an embankment PFM.
Which is that, I mean, that's the first time I ever heard that we really have potential risk of overtopping, because again, I think we have an emergency spillway. Once it gets to a certain level, all the water is going over the top of that and doesn't, and I don't know, I'm guessing my assumption might be wrong, couldn't overtop the embankment because we have that emergency spillway there, right? But if a PFM is an overtopping, if that's one, wouldn't having a low-level outlet directly connect to making sure that doesn't happen?
Yes, yes, but the embankments team are considering PFMs that are related directly to the embankment. The low-level outlet team is considering other PFMs. And so if you look at it more broadly, yes, it absolutely does. And that was really the origin of the comment. Right. From the IRB.
But you guys are always saying, look, it is obviously necessary, even if it maybe doesn't directly connect in your.
It would be
Go ahead,
more
Janelle.
the
Yeah.
intervention side, it seems, two PFMs that are identified. The low-level outlet system could be used to intervene when you see those potential failure modes like overtopping going to happen. An intervention would be to use. So it doesn't correlate to a PFM specifically, but it does, it helps almost all of them.
Right.
Yep.
Yes.
So excuse me, this is Les Iyer with HDR, part of the CNA team. Just wanted to amplify what Dan and the last speaker were saying, is that you're both absolutely right. And that will be looked at when these measures are combined into plans. At this particular phase, the people who are working on the low-level outlets were not that familiar with the risks associated with these other facilities, like overtopping on the embankment or issues on the FCO. And so they just weren't able to estimate those risk benefits at this phase. But as they're combined into plans, in the next month or two, then those issues will be grappled with. So you're absolutely right. We just haven't grappled with them at this point in time.
Right. And the intent will be that it will.
Yes.
Okay. This kind of goes to an earlier point that we made is in the report, in talking about the PFMs associated with the emergency spillway, we say, hey, the two primary considerations are tailwater to the Hyatt power plant and scouring of the hillside that could undermine the secant pile wall. I think we've pretty consistently said, hey, there's also the impact downstream, in terms of huge amounts of debris going down, and affecting, the downstream areas as well, right? Not to mention, like, hey man, if the emergency spillway is in effect, there's a lot of uncontrolled water going down the system and that is gonna have an impact on levees downstream, right? And from just my perspective, that's actually a more serious public safety consideration than whether or not we lose Hyatt power plant. Because as I've been told, Hyatt's not really necessary to running the dam itself. It's not a power source for running the gates, that we have all these other backups. That's what I've been told from previous, right? So really, losing Hyatt, yeah, is a big problem for power, right? And those who need that power, which none of us benefit from, you know, I'm just saying, you know. But to me, the greater public safety risk is, you know, what that water is going to do down to the downstream communities, right? And I feel like that's still, I feel like that wasn't enough of consideration during the event itself. And then we know from the forensic report that, you know, man, if we lose Hyatt, that's going to be a disaster. And that was a big consideration for people in making decisions. And then I see it show up again here. It just kind of bothers me. I mean, and I feel like that's something that is shared by the community is, hey man, like what's more important, like making sure that power keeps getting produced, which I know is a economic benefit to the project as a whole, right? But I don't know how much it really plays into a public safety benefit, especially as weighed against, what's happening downstream and when the emergency spillway goes into effect, right?
So at the level of storm that's occurring when the emergency spillway is used, at that level of storm, even if everything works perfectly, there's still going to be so much water downstream. The levee system downstream is going to be so overwhelmed that all those public safety issues are going to exist, even if everything at the dam works perfectly. So I guess that's how we're separating this, is we don't want to at all diminish that all of those issues downstream.
It kind of depends on the size of the storm, right? I mean, in the 2017 event, we didn't have, it wasn't 320,000 CFS intake coming in, right? Go ahead. Yeah.
There is one other link, John,
Right.
and that's that if we were to lose Hyatt, then we lose the ability to regulate below 813. And so, and if we lost Hyatt, it might be for some number of years before it could be restored. So this links also to the additional consideration for a low-level outlet. But
Right.
you want to be able to control the reservoir to create that flood reservation storage down to 775 or wherever we have that. So that's one of the reasons to keep Hyatt viable.
Right, but at max, it produces, how much does Hyatt bring out? Is it 16,000
About 15,000, yeah.
Right, and that's when all six are working,
Yeah.
and they haven't been. They're still not at
Right.
all six working.
Yeah. No, it's
So-
not an argument against.
So it's not a lot of
new
water, right?
low-level
Yeah.
outlet. It's just essential to maintain that flood reservation pool.
And I agree, and it also, that's really how we deliver water in the summer,
Yeah.
right, as we use Hyatt. So I get those benefits, but I'm talking about in these events where we have the greatest public safety concern,
Yeah, and
16,000, 15,000 is like, it's a trickle, man.
Everything
Yeah.
you're saying is absolutely correct. But what the team was tasked with was looking at all risks at the facility, no matter how small or how great. And I think when you see how they plot, as far as the likelihood, the consequences, lives lost, it all comes out to where each risk is identified so that we can then figure out how we mitigate all the risks, because we want to know everything, what are the risks everywhere. Because you can also have different scenarios that add up as they plotted through, where one thing compounds to another thing to another thing. And so that was what they were tasked with, is looking at all risk, plotting them, and then saying, okay, where is the highest risk? And obviously, water flowing over emergency is a very high risk, very high risk. So.
Right.
There is one other link to this in the bigger chain, and that's that we haven't heard too much about the operations task yet. And so when these alternative plans that we're talking about get put together and start being evaluated, then the operations task will be looking at, well, how might these considered new facilities be useful in the future work of the water control manual and forecasted operations.
Well, that'll be good. I think they do connect, but I also would say it's almost, yeah, as you said from the beginning, it's further evidence of a need for a low-level outlet. And I guess really the crux of where I was going with that comment is the risks seem to be evaluated, the risks are to the facility itself.
And it wasn't meant to be that.
Right. And I think what you've heard consistently from us is like, well, there's also risks that play in downstream of this facility. And that's really one that we're primarily concerned about. And I get like in the super flood event, I mean, we know, right? But it's the events that maybe are not super flood, but if we manage them appropriately, maybe you don't have the kind of impacts downstream, flooding, et cetera, that are, you know. I mean, really, it's just about, to me, the broader picture is, this really is primarily a water storage facility, right? That's primarily what Oroville is. It does have other benefits, including it helps with flood protection and metering out flood flows downstream. But primarily, it's a water storage facility that we want to make sure is operated safely in all different scenarios, right? And this is one of those scenarios that happens, and, you know, all right, I've probably gone off. And I know we're going to get more into the emergency spillway stuff, so we can kind of dive into that more
Just
later.
maybe wanted to add that we appreciate those comments, Assemblyman. Our you know, analysis is focused on the facilities. The one regarding erosion does lead to kind of that public safety concern you're talking about.
And we want to avoid erosion as much as
Yeah.
possible, no matter what, and that's the point, right?
And I will add that you're right, water supply is a big component of the facility, but so is flood control. So that those two combined are really major purposes of this facility.
Right. I would say, but I would just caveat primarily water storage, right? I mean, the Fed's bought in, what, 750,000 acre feet? And what's the rest?
Yeah, so it's
So again, I mean, it's
a little over
primarily.
20% of
Right.
the purpose of the facility.
Right.
That, you know, by leveraging the resources for both purposes, the facility was able to be built at the size it was to provide both benefits.
But a lot more state money went into this thing than federal, right? That's why it's a state project. And what was the purpose of the state state water project? So, I mean, we know that, I want to just continue to caveat that, because that's why we built Oroville. At its really most primary motivating factor is building that and the aqueduct and, you know, everything that goes with that, right? To have water sources for the entire state, which is fine. It's just that it needs to be operated safely for the community that hosts it. That's, I mean, and we know that we get flood control benefits as well. Nobody's denying that, you know, but it's just like, they probably didn't build it just for that reason. We all know that, right?
Yeah, that's right, it's
primarily on,
multi-purpose.
You know,
But
Governor
flood
Brown.
control was a catalyst that helped.
Just to
Yeah,
add,
go ahead.
don't be afraid to say it, it's on your guys' website. The Oroville Dam main purpose is water supply for the state of California.
Okay, sorry, I mean, I know we probably, any other questions or comments on that?
I got a quick one, quick answer. In your comment number 5, suggesting that all supporting analysis be peer-reviewed prior to considering it complete, what's that look like time-wise? Is that something that will fit within the time frame of the CNN's?
I'd like to bounce that to the project delivery team.
Yeah.
There was a recommendation made.
There's been a history of the past of analysts not being peer-reviewed, such as the geology of the hillside of the emergency spillway was never peer-reviewed, or, so this seems like an important comment or recommendation that the RB has, if you want to.
In our discussions, Matt, with the IRB following that comment, they advised that that peer review is meant to be an internal project peer review, a quality control effort, not an external peer review of a different nature. So they wanted to be sure that there's some pretty technical work that Betty mentioned, that scour erosion analysis, and then there's been some other structural analysis for how the emergency spillway apron is going to perform under load, and so those are the things that the IRB was interested that we're getting checked again by the project resources, other than just the folks that are generating the technical work.
I'm really pleased with the amount of work that's gone into the study. It's just given past history, that makes me want to ask, where does independent oversight come in? Does the IRB have the opportunity to sort of peer review some of this, the accuracy of some of the analysis on their own, or is it just trusted that it's done internally?
Our job is not to review in detail the technical work, and we leave that to the project delivery team to identify internally within the team resources appropriate independent reviewers for documents like the supporting analyses.
Could the same be said for the scoring that they did on the risk metrics, that's beyond your function as an IRB group?
For individual scoring decisions, yes. We look at the collection of results, we look at the process that was used, we look at the people who were engaged in it. We evaluate it at that high level. We do not look at every single decision made in constructing the event, the risk results.
So the main source of independent review would come in comparison to the independent consultants in the Part 12 and Level 2?
That's a very powerful place. We recognize the value of making that kind of comparison, and the results compared quite favorably. The team is still in the process of looking at the handful of circumstances where there were greater levels of difference in the overlapping analyses to make sure that nothing was overlooked. But the processes were a bit different. Great that there were some areas of overlap, and it's a wonderful place for the team to be able to compare their thinking to what came out of Part 12D.
And in the reading, it sounds like that's still in progress and something that we may hear about in the next meeting?
I don't know in terms of meeting presentation, but it was still in progress when we met in mid-October.
Still in progress?
It's still in progress, and so it's still, the CNA effort, level 2 effort are still comparing results as the level 2 concludes.
Thank you.
Just wanted to comment about the independent review, peer review. Some of the studies that the CNA team is using and the level 2 risk analysis, such as the hydrology studies that have been recently done or the seismic studies, those are peer reviewed by the regulatory agencies, by FERC and DSOD. So they, both agencies are currently are reviewing or in the process of reviewing the hydrology study, which is about a year or so old. They will be reviewing the seismic study, seismic hazard study that is just being completed right now, that both groups are doing. With regard to the Part 12 process, the part of the Part 12 process is the level 2 risk analysis, which is actually a good check or on the potential failure modes and likelihoods and consequences that the CNA is doing. So that's, I don't think it's an unprecedented parallel effort that no other dam agency is doing. You don't have two different groups doing this. So that's unprecedented. And in addition to as part of the Part 12, there's another board, the independent consultant, that is going to be, as part of the 5-year review, does an independent review and inspection of the dam, review of updated studies, review of performance, and so on, and has been sitting in on the level 2 analyses. So you have that other independent review. So there's quite a bit of independent peer review on various aspects here.
Okay, thank you.
So if there are no more questions, we could jump into then Sergio talking through the condition assessment.
Good morning, everyone. My understanding is that you guys have had an opportunity to review the presentation, so I'll probably move through it a little faster than normal. But if there are any questions, either myself or others from the team will answer those questions. So the discussion points for today, I'm going to quickly touch on the project schedule, and then basically where we're at with, status-wise with both the existing conditions assessment and the development of the measures to reduce those risks. This schedule is the schedule that we presented to the IRB. We met with the IRB October 17th and 18th. So as of October, we had completed our preliminary work with the PFMs and also the risk reduction measures for those PFMs. And we were in the process of starting to formulate plans. So we have the CNA team, integration team has started with the plan formulation. We have gone through a couple of iterations. We started with, and this topic is going to be something that we're going to dive into further at the next meeting, but we started with 12 different plans and have narrowed them to 7. They may go up or may consolidate some more, but as I mentioned, that'll be a topic of the next ad hoc meeting. You guys have seen the slide before, so we started with 171 failure modes. There were failure modes that were put together based on prior Part 12Ds, brainstorming sessions. A lot of them we included, this time failure modes that were previously considered but not developed were included. We wanted to be all inclusive. During the L2RA sessions, there were some brainstorming sessions, brainstorming done, and these failure modes were increased. Under the CNA, we also did additional brainstorming, so we increased that number to the 372 that you guys have seen previously. So the facilities that we looked into, by now you guys should be very familiar. The emergency spillway, the FCO, both the headworks and the spillway chute itself, the low-level outlets for Hyatt, Palermo, and the river valve outlet. And as part of this, as we talked about earlier today, one of the considerations that we're looking, or a measure, is a new low-level outlet. So that's that task. And then the last one is looking at the 3 embankments, the main Parish Camp and Bidwell Bar, saddle dams. So here's the 372. 247 of them were screened out for various reasons. A lot of them, when different teams, different years, they submitted these potential failure modes. A lot of them were very similar to one another. So as part of this process, the teams did some consolidation. So that was one of the reasons for the reduction. A lot of them, or others, were considered but not developed. Some were actually, they went through the inventory, but when they completed that inventory, the likelihood of failure was so remote that they went ahead and discontinued it. So we ended up with 125 potential failure modes at the end.
So could you give like some quick examples of stuff that had such a remote possibility of happening, it was ruled out?
I think I'm gonna let the experts back there.
Okay.
Well, one example that was ruled out by both the level 2, one example of a PFM that was ruled out by both the level 2 risk analysis and the CNA team had to do with the potential for a large earthquake making the core block monoliths move and deform relative to each other during shaking, and then also relative to the core. That was ruled out because those monoliths are embedded at depth. They are keyed very much into a highly irregular foundation, and there's just such a remote likelihood that they could ever move relative to each other that was ruled out by not only the international experts, but also the DWR CNA team.
Now, things that were carried forward, now we carried forward things that were on the order of like 1 in a billion year, or, you know, so by when we say remote, I'm just, like, how remote are we talking here with, I think that's maybe a word that we're getting hung up on, like we're.
Maybe I have some other examples that'll help John. So when we looked at the emergency spillway, I think there was like 50, 59, something like that. And so one of those was that if you remember out there on the apron, you have these roller compacted concrete walls that are on the outside edges of that go up 20, 25 feet above the surface of the apron. And so one of the failure modes that was considered was, well, what if the water rises and now it was able to seep around the outside of that RCC wall, and in its seepage, if it would start moving material, eroding it, internally unstable material that would pipe and then cause a void, and so you'd get an erosion on the outside of the spillway wall. And in looking at the construction, how that was built, that concrete was placed right against the rock, so that was judged not to be capable of happening. Another one on the emergency spillway was, you know, the hill goes up, the abutment up above the top of that emergency spillway wall on the right side. There's a road that kind of goes along over the top, and then the hill continues to go up. Said, well, what if that hill got so saturated in a great rainstorm that you caused a landslide of that hill up there to flow over the top of the wall and then into the spillway? Could that block this spillway from functioning, and there just wasn't enough material above that elevation for that to happen? So it was more things of that nature which were dismissed, but things that were carried forward, like John is mentioning, we looked at, well, what if the emergency spillway starts to flow, and it flows at 50, 75,000 CFS for a long, long time? Then what's the failure mode that's going to come back and challenge the integrity of that weir like it did in 2017? Well, you'd have to first erode out the secant wall. Then you'd have to erode under the apron, and you'd have to, and that's 60-foot deep secant wall, 10-foot thick apron placed on formational rocks, so that one ended up being carried forward, but it ended up with a likelihood of occurrence of somewhere down greater than 1 in a million chances. So those are sort of some examples of things we looked at.
To be responsive to your question, John, about what kinds of likelihoods we are carrying, we're carrying likelihoods that are rare as 1 in 10 million, 1 in 100 million. And some of our task teams got really excited and carried things as much as 10 billion. But they're there. And some of these were not developed by the level 2 because they considered them to be negligible, but we do have some of those that the level 2 did not carry forward. One of the things going on in the emergency spillway, just to touch on that again, when we're talking about the hillside erosion, we're talking about a much more likely event to happen, something on the order of maybe 1 in 1,000 chance in a year, a 1,000-year event, versus the kinds of things that we are looking at for the secant pile wall. That's like something on the order of 1 in 10 million.
Okay.
Thank you. So further explanation on the 247. And as I mentioned previously, part of it had to do to duplicative PFMs that were offered by different participants brainstorming sessions. Some PFMs did not make sense or were physically impossible, and I think you just heard of some of those. Some PFMs had such low likelihoods, probabilities of occurrence, that they were not carried fully or forward. So this is a table, and I'm not going to go through the entire table. I think we start off with the total of the 372 screened, consolidated, that were eliminated. We're 235. As I mentioned previously, we had some that we went ahead and developed, but at the end they're not carrying forward because the likelihoods were so low. So we ended up with 125. You've also seen this matrix a few times. We started off with our asset management matrix and modified it to meet the needs of the CNA or any dam project, simply because the original asset management life loss went only to 1 in 10, and as you can see, we're in the thousands for a maximum. So we did consolidate a couple of the categories, consequence categories, public safety and personal safety. We just consolidated that into a single category, public safety. We kept compliance as it was. We also kept flexibility and reliability of water delivery and other state water project purposes, and the financial impact. Not sure what happened. Oh, no, it's right. So this is the expanded matrix. I'd like to touch on a few items here. The dashed lines, those are in essence the tolerable risk lines that is used by the federal agencies for FEMA, Army Corps of Engineers Bureau. They all use this as part of their risk analyses. Items above the dash line, there's an impetus to develop measures to either reduce the likelihood of an occurrence or the consequence of such occurrence. The area that's bounded by the dash and the dotted line there. This is the intermediate risk area. Risk in this area are tolerable only if reasonable, practicable measures are examined for potential implementation and implemented as practicable. So this is the, you guys have heard the term ALARP a couple of times previously. Below the dotted line, this area, there's lower risk. In this area, you know, we're also asked to look to see if there are any measures that are reasonable, practicable, that could be done to reduce the risk even further. The gray zone, the federal agencies had this gray zone in there simply because of the great life loss, you know, life loss above 1,000. But one of the things with this is that it's very difficult to calculate the extreme low probabilities of an occurrence. So the federal agencies have struggled with that gray box, and I'll probably ask Les to elaborate on this a little more because he's extremely knowledgeable.
Well, I don't know about that buildup, Sergio, but the gray zone there is an area of special concern just because the potential for loss of life is over 1,000. And it's also an area of very low likelihood. The probability of this happening is very extreme, very low. But as a result, because of the potential for loss of life, the federal agencies have encouraged people, their own people, their agencies and others, to look at those things as a case-by-case basis. And so even though, and to be sure, if you're in that gray zone, your likelihood of having this happen in any 1 year is less than 1 in a million. And so that's pretty low, but the consequence over 1,000 loss of life is pretty high. So that means it has to be looked at a case-by-case basis. And the PFMs associated with Oroville that fail in this, they have nothing to do with the spillways or the outlet. They only involve the potential for the main dam. That's the only feature that could actually fall into this zone. It's the only facility in the complex that can lead to this potential loss of life. So the PFMs that fall in this zone are all associated with consideration or a thought of what if something happened to the main dam.
All 18 of those?
Yes.
The last item on here, the IRB recommended that we add some additional colors to the previously matrix. Previously, we had just green, amber, and red. They asked us to divide the red into a lower and upper, and likewise with the green into two, a light green and dark green. Now, moving on, before I go through these next few slides, I want to reiterate, you know, we're still working on this, so this information is still preliminary. As Betty touched on, we're going to go through the failure modes and see where intervention was not used in their inventory or nodal analysis, and those risks may reduce as a result of incorporating intervention.
I think we've all looked at like the PowerPoint.
Mm-hmm.
So I get, so there's 4 that are in the lower red, you know, there's 18 that are in the gray,
Right,
I think we all know that where those measures have lined up.
okay.
I think it might be better, just like, what are some of those things, what are the four that are obviously seem to be the highest risk that we have to mitigate? And then I'm kind of curious about Amber, because Amber is still in that area where it's in between those two lines that you pointed out.
Right.
So I don't know if, can we kind of maybe focus in more on that? Because I think, I mean, I see in the next slides, like, I know where things line up and, and that's what it's categorized.
I'll certainly do that, as much as I can due to CAII.
Right.
Maybe the one thing to point out on the slide with the zero and the red is one thing with the Mojave Dam, the core dam has been in the news lately, and so we were, where would that plot just kind of get us relative sense. And so that, as we were just reading what's in the newspaper, you can kind of get a sense of where that might fit. And that would fit up there in that upper red zone. Just to give a little bit of context, how does Oroville compare to us? So,
Mojave would be an upper red because it's got a core problem.
because it's the frequency of the storm, kind of ballparking what the frequency, so give the probability, and then the number of people downstream, and kind of what the potential for life loss would be. That lets you kind of plot on that chart a ballpark where it would end up, and it would plot up in that upper red there.
Okay.
Mojave River Dam, Southern California, population at risk is over 300,000. That's over twice the population at risk for Oroville. It has, the Corps of Engineers last week announced it has a likelihood of being overtopped during an extreme flood that's actually more frequent than anything we're talking about at Oroville. So that's why it would plot way up there in the red.
It is not, it's a Corps of Engineer facility.
It just showed up in the newspaper a couple of weeks ago and thought it nicely fit with what we're talking about here is the reason to bring it up. But
Okay, now, talking about the four that plot in the lower red zone. One we talked about earlier today, the emergency spillway and the impacts associated with that. Another one has to do with a large seismic event, an event greater than 30-year annual chance.
30,000.
30,000, thank you. Makes a big difference. Results in sliding or shifting of where the structure and the embankment, that interface, that movement causing that interface to lose contact and potential erosion occurring. The other one has to do with failure of the FCO gate system. And the last one has to do with overtopping of Parish Camp. But it's overtopping under an event that's 1 in 100,000 years. Under the
1,000-year flood?
No, it's 1 in 100,000.
So larger than the PMF.
So a PMF is 20,000? This is 100,000.
It's greater than the probable maximum flood?
Yes.
Okay.
Yes. So under the probable maximum flood, all the dams still have 2.5 feet of clearance. So this one, we looked at a much greater event, 100,000-year event.
And I'll just add sorry, Matt. Assemblyman, you had a question earlier about, hearing of this scenario, and we did too, and it really is for an event, bigger than the PMF. So as part of this study, we're taking the approach of, looking at things very, very cautiously and looking at, the most extreme events to be thorough.
Why wouldn't that end up in the gray? Because we've never experienced the PMF for sure, and this is even greater than the PMF. We have to plan for the PMF, right? But this is greater than the PMF, and right.
The threshold for entry into the gray is 1 in a million.
Okay,
And so the PMF, 1 in 20,000, so the 1 in 100,000 is much rarer, much larger than the PMF, but that's still more frequent than the gray. So just saying the threshold for getting into the gray, just trying to give some context to what we mean when we say 1 in a million years, how rare that is.
Another reason, John, is
Yeah.
that this is for Parish Camp Saddle Dam, which is only like about 25 feet high. So the consequences associated with that dam going are small compared to Oroville, the main dam. And so actually the main potential for loss of life, if Parish Camp should be overtopped and eroded away during a 100,000-year event, is that it would cut off evacuation from other areas that are already being flooded. And so the potential for loss of life is not even near 1,000. So it can't get into that box at all, just because the potential for loss of life is a lot lower.
Yeah, that's,
Well, while we're on this topic, some of the measures that were recommended in the summary sheet, I think, talked about raising the height of all embankments by 3 feet. Does that have anything to do with the probable maximum flood letter that FERC challenged you on wave run-up, overtopping the dam by 4 feet or so?
So if I could maybe touch on that, the potential or probable maximum flood, the most extreme flood events that regulatory agencies ask dam owners to do, we recently updated that about a year ago.
Did we meet the satisfaction of the FERC October
I
letter?
think that's under discussion right now. But they sent us comments, I think we sent responses back, and I think that's being discussed.
We have comments both from FERC and DSOD, and the issue is, do you get the maximum wave run-up coincident with the peak reservoir stage? And there's a lot of, DSOD made actually more than 10 comments on that issue alone, having to do with wind direction, historical database information, the application of probability and statistics to that. So we're working our way through that, and we're just partway through that right now, Matt.
But with, for instance, the still water elevation is 2.5 feet below the official top of the dams. So it meets the PMF criteria for the most part. There are many dams in this state that do not meet the PMF currently. And there are many in the Bay Area that are protecting urban areas that are potentially overtopped by 3 to 7 feet. And so by comparison, Oroville meets the standard. For the purposes of this risk analysis, we considered floods way and above the PMF, just to see what they would do or what their likelihood is. So we were looking at floods that the still water were at the top of the official crest of the dam and also maybe 2 feet higher. That's the 100,000. For the main dam, Oroville, much of the dam was raised 5 feet higher during original construction in order to allow for settlement. It still has most of that 5 feet in the central part and is amenable for flood fighting. We talked about the need for considering intervention during a risk analysis, and flood fighting is an intervention we use all the time for levees, and we can easily protect against a few feet on a dam that has a limited length. That's true for both the main dam and Bidwell Bar Canyon Saddle Dam, which is nearby. It's less likely to be successful for Parish Camp because it's further away and more remote and difficult to get to during a flood event. So that's why Parish has been singled out because the potential for intervention is lower there.
May I, for the sake of trying to get us back on track and timing here, I think the focus we agreed to today was on the 2 spillways, looking at what are the areas that could potentially, we could see some of these measures to improve reliability and why. So I think just for the sake of time, we've got an hour and a half transition into specifically on those 2 spillways. I know we don't like the word concern, but that's in my mind how I think about it. What are we concerned about on those 2? and maybe it's the 22 and the 4, and what are we contemplating doing in order to alleviate those concerns?
What I just want is like a quick outline of, hey, what are the ones you already talked about the 4 that are in the lower red. What was identified in the amber? And then maybe we can move into the
Get into the measures.
on the spillways and flood control.
Okay.
Yeah, that sounds good.
Okay, with respect to the amber and what Curtis just said, there's a total of 21 PFMs there. For the emergency spillway, it's what Steve mentioned earlier. That's a failure of the secant pile wall, leading to progressive erosion up into where the monoliths are lost. For the
May I interrupt? I thought that was the first one of the 4 that we just spoke about earlier.
no, that was erosion downstream of the apron.
Okay.
So the first, a lot of erosion downstream occurs, and then it deposits material, which backs water up into high. That's the first one. This one's,
This one, you have a
different.
major event, you lose your pile, secant pile wall, and it progresses up to the monoliths.
Okay. That's an amber one.
That's an amber.
Okay.
For the gated spillway, structural capacity of the FCO headworks structure during large shaking, an event greater than 30,000 years earthquake.
An earthquake. Okay.
So those are some of the examples, or 2 examples for the amber.
Okay.
Should I just go ahead and
I
Move
mean,
to
if it's
measures?
something that you could share with us, what those 21 were, like, just a list of what those things were.
Hey, can we talk a little bit more in detail, Sergio?
You don't have to do it right. I mean, if we want to get into these other things, which we do.
I think which of the 22 relate to the 2 spillways?
I would have to go through the all
Right.
the information.
Can we just get a listing of the 21 that were identified in the amber area?
Yeah, I think we can.
the struggle we're having is not wanting to get so specific that we feel like we're creating we're sharing too much about a specific vulnerability that we're creating a security concern. So that's why we're looking here. So we want to share the concepts and convey, there's facilities where we have some vulnerabilities that we want to pursue further, but that's where we're just trying to do that, and we're trying to balance those things there. So I think the request, Tim, how characterizing what's in the 21, I'm not, we're hesitating on saying, we'll give you the itemized 21 list, but it sounds like more than just the 2 examples we gave, trying to strike some balance.
Yeah, I
in
mean,
those is
and,
what's
okay,
the
I realize
request
there
is.
might be some specifics you can't relay, but the general concepts that, the PFMs, right, that were, concepts of the PFMs.
Some characterization that doesn't point to exact same.
Without getting too technical, like you're identifying the things that are a potential risk, right? And the measures are designed to deal with that risk that you've identified, right? All of which is stuff we'd obviously like to know, right? I mean, it's.
Yeah, I think general characterization may be the way we can do it, Assemblyman, and as we go through the measures, we can probably talk about how they connect, so that.
That's fine, and so we'll just mark that as something that you guys can look through, and if you can deliver us, a listing that maybe takes out if there's any details that are a concern from a public safety or CII standpoint, but it gives us the general concept that's being looked at. PFM is being looked at.
I think we could maybe look at that with the law enforcement. They had concerns too with what some of the details, and so I think we could find ways to strike that balance, so that both sides are concerns are addressed.
Right. Okay. Well, we'll work on that. But maybe now we can just transition into, hey, what were the big things on the spillways? And what are, some of the measures that are under discussion, I guess.
So we're gonna fly through this presentation now.
Yeah. I mean, we've read through this, I think, so
Okay.
you're not,
So with respect to, some of the examples of the measures, in particular to the emergency spillway, one of the things that we're considering is constructing a new gated spillway within the vicinity of the emergency. Let's see, in terms of.
so would that be a redundant spillway? Like, you'd still use the old one and also use this one?
It will be redundant
Okay.
to what's out there now.
Okay.
It'll provide some flexibility, reliability. With respect to improvements to existing facilities, when it comes to those two structures or facilities, reinforcement of the FCO headworks, armoring the lower emergency chute, and once we get further into the actual measures, we'll see what they are. And I think that's about it for those two. The other one is reconstructing the main dam and right abutment contact at the FCO monolith. It's kind of tied to both the embankment and the gated structure.
I have a quick question.
Yes.
When you're looking at the likelihoods and even developing the PFMs for the FCO headworks, is the fact that a lot of those materials that were used for it have reached their, 50-year useful life, is that being taken into account, or are we just using like construction specs and historical data?
I'll start and maybe Mr. Sarkeesian could elaborate.
So the existing conditions were evaluated, and we have quite a bit of documentation on inspections for the past couple of years, testing, and all of that sort of information was provided to the teams to evaluate and really see what is the current condition, recognizing 50 years of service.
All right, thank you.
So this is an example of a risk reduction. So if we were to RCC or construct an RCC apron from the existing secant pile wall down to the diversion pool, what would that do to the risk for this particular PFM? So it currently plots in the, I'll call it pink box there. After we implement that measure, it actually reduces the risk down into where there's no life loss or any other impacts, financial impacts or anything. Yes.
Just wanted to point out that that particular measure that protects the unlined spillway from erosion also helps support the secant pile wall, which is the other PFM that was considered worthy of being carried forward. So it does double duty. Many of these measures address more than one potential failure mode, and that's one example of one.
And that was the end of what we did with the presentation, but our thought was we sent around the sheet of the measures, so we thought now for this part and going through the measures, we'd just walk through what the items, what they are, and we thought focusing on the emergency spillway, the flood control spillway, starting there, so that would be the ones. So the consolidated candidate measure ID, the T1 is task 1, so those are the emergency spillway. The measures generated out of that task group, and T3 are out of the group working on the flood control outlet.
Okay.
Do we have those?
Yeah, the list
And
of
it sounds like, just, on this quick, I mean, one of the things is, hey, just line the whole emergency spillway, right?
Bottom page.
That's one potential measure. But it sounds from what I'm reading in the report and just some of the things, it seems like you're saying, yeah, that would take it to, almost zero, but it's also really expensive to do.
Right.
And there might be another thing you could do that gets you the same, or gets you similar risk reduction. And it sounds like maybe people are centering around a lined channel that would maybe,
And the other,
they're not centered, but, right.
and the other, oh, I was,
You haven't made any decisions yet, but those are different alternatives being considered.
Right, and I, maybe Steve might want to talk about how they plan on moving forward from here, but everything that you see here are being considered at this point, and are going to move forward. What combination or what different things give you the most risk reduction for different scenarios? But
Okay, well, maybe, do you want to just walk through those, the T1s, the emergency spillway measures?
yeah, I was going to add, the other thing is there's not necessarily a one-to-one mapping of a measure fixes a specific PFM. There's low-level outlet has a benefit for a wide range of different
Right.
vulnerabilities. So that's, and then also as you do combinations of measures in the plans, you also get different benefits there. So just that lack of one-to-one mapping, I think is an important point. But that was the end of my point I had. So,
So you want,
Maybe just walk
Yeah.
through some of
like
these
some
different,
elaboration?
yeah,
just walk through some of these different measures that you guys have.
All right, so you're correct in that some of these are, would provide greater reduction in erosion and deposition than others would, and some of them are just different ways of treating the problem. So T1A, an improved hillside downstream of the secant pile wall, conceivably you could go downstream of the secant pile wall and excavate away a lot of the material that might be eroded if you had a large event passing over the emergency spillway. So you could strip that rock out and locally reinforce it and stabilize it so that you could increase the flow capacity up to say 100,000, 150,000 CFS and still not have excessive debris deposited into the channel. So that's one way that you could look at doing that, but that doesn't, that wouldn't, it wouldn't be feasible to stabilize that whole hillside by that means for flows up to the PMF. And so this is where it's going to be in the decision-making, how much residual risk do you want after you make these improvements? And that's what you were speaking to is how much do you, eventually, how much do you want to spend, how much do you need to protect it versus what type of residual risk can you sustain? So then T1AU, a new structural concrete spillway chute with an adjacent RCC extension. So if you can conceptualize over there where the emergency spillway is at, you would excavate another entrenched channel similar to the existing FCO, and you could make that of variable size so that you could make it narrower or wider depending on how much flow you wanted to put down that new chute. And then on, and that would be a gated facility so that you could take varying amounts of flow through that type of chute. But then if we're sort of standing on the crest and looking downstream, that chute would be situated pretty near the alignment of the existing FCO. But then on the far right wall, you would construct an RCC berm wall so that at the highest flows, you'd still be taking some excessive flow over the now emergency spillway weir that's not controlled by gates. So you'd have 3 conveyance structures in that concept.
And what are the benefits of doing that?
Right now, the benefits are all the same. So they're gonna be a reduction in the amount of erosion and then a protection of that secant pile wall from being eroded, head cutting back up to the structure. And so there'll be, what we'll enter into, why would you choose one from the other? You'll look at how much does one limit the erosion and deposition, and you have to ask yourself how much limitation is enough, because you could, if we jump ahead and said, okay, we could put down a brand new gated structure similar to the existing FCO that would take 450,000 CFS. Well, now you could, in that concept, you would pass the entire PMF with no erosion and no deposition into the river, so you might choose that. Or you could go to the end of the existing apron and now continue building that apron in a wider structure. Say it'd probably be 400 to 500 feet wide. Take that all the way down to where it enters into the pool downstream, and so now you would have the overflow weir, but you'd protect that conveyance all the way down, and that you could build that so that you also would not have any erosion, and you would protect the end of the secant pile wall. If you wanted to say, well, some erosion and deposition is going to be acceptable, and if we say the combined
Excuse me.
flow, the combined maximum discharge for the PMF is going to be 723,000 CFS. If we can take 300 through the FCO, and now we want to protect the emergency channel, we want to take an additional 250,000 over there with no deposition. Now you could do a combination of different things to get that, like protecting the secant pile wall with an enlarged cutoff berm, if you can see that. You'd excavate downstream of that secant pile wall, deepen it, and then maybe build back something that looks like an overflow end at the toe of that structure, and then you could selectively reinforce the channel or pave a channel of varying capacity up to 200, and now you have a combined flow of 500,000 cubic feet per second, and maybe that gets you to a return period associated with a risk reduction that you're happy with, and you think that's a more balanced risk approach to treating the entire facility. So this array of, and here's one listed here that I don't think really.
Let me just caveat.
Go ahead.
All these are assuming like really significant events that
Extreme
we've actually
storms.
never experienced so far.
Nowhere close.
Far beyond what we've
Right,
ever seen.
so I want to caveat that so people aren't thinking,
Yeah.
oh yeah, we're going to send 500,000 CFS.
Right, right.
Because, and it also connects to operations, which you talked about earlier, which is, and so far to date, we've always said, hey, 150,000 is really the maximum that we want to send down.
Right.
Considering the levee system.
And so operationally, when you create a new gated spillway, then you have more control over the reservoir versus where you're just lining the channel and counting on the overflow.
Right,
So
and the redundancy there is also a benefit, right?
Correct.
Yeah, okay.
A benefit to
So
Say that
that's
again,
kind
say
of,
that
the-
again.
It's a redundancy for failure modes in other facilities, so it's a redundancy to the FCO.
so did you want more elaboration on that array, or is that good enough to cover the variety of things?
That covers all those that we, if we keep going down.
Yeah,
Maybe go to the next category,
Yeah.
to the,
T3s,
to the FCO?
Or- let's-
or
Yes, FCO.
Okay.
Yeah, I think you already covered unlined step spillway, or did you?
I did not, and so what that is, that concept would be that you would now cut into the moderately weathered to fresh rock. You'd cut in a new channel, and this channel would be an unlined channel, and it would be very wide and very deep, and so it would come down from the end of the apron all the way to you get to the waterway, to the diversion pool, and it would be probably a trapezoidal cut channel that's maybe 40 to 50 feet deep, cut into the rock, and it would step down the elevation drop as you go. So it'd have these plateau type structures channelized that would come down. And I think with the nature of our rock, we saw that you know, the power of the stream and the fracture patterns in this rock, you still would likely have to reinforce rock bolt or somehow otherwise protect in that concept.
Okay.
And some of these, you know, as we're talking, you probably for yourself can say, gee, that one doesn't sound quite as good as some of the other ones, or as reliable. And so that's the kind of thinking we'll be applying as we consider the different measures in conceptualizing plans, which will be combinations of the measures.
Okay.
But T1P would be noteworthy, just being a little different than the other ones above it. The other ones kind of have that theme of what work can you do over by the emergency spillway downstream there, where T1P is a little different.
So T1P is really reinforcing the end of the Hyatt discharge, point of discharge, so that if you, then in this one, you let erosion go, you inundate the diversion pool, but you've now blocked the waterway back into the power plant, and so you've prevented it from being damaged and taken out of service, but you would have to go in after the event and re-clear that channel, dredge it so that you can open it back up. So that one would be allowing.
Right, that assumes erosion and blockage.
Yeah.
But you're protecting the power plant with logs and bulkheads.
And so this measure.
Stop logs and
as we're
bulkheads.
looking at different plan concepts, is often being considered along with one of the other channel improvements that limits the erosion. So you might put in bulkheads here and improve the channel, limit the erosion, so that you have kind of a double safe measure there.
Okay, then you looked at RCC crack repair and also armoring the RCC apron with structural concrete, but you didn't carry that forward because the likelihood is so small
That's correct.
that would be undermined.
Yeah, so you want some explanation on that?
Whatever you wanted to add to that.
Okay, so one of the things to think about is what is the integrity of the RCC apron under heavy flow, and is there a scenario where you could damage the RCC under extreme flows, or there are actually cracks currently in the RCC, as the concrete is cured, it's developed fraction of an inch wide cracks. And so you can go in there and repair those cracks, pressure grout them shut. But when you put together the sequence of events for the failure of that apron due to hydraulic loading, the eventual charging of those cracks, the rocking of the RCC apron, then the plucking of that apron, and then progressive undermining erosion, the likelihood of that sequence happening is in a single event is not very long. Perhaps that could happen if you had extreme flows over that RCC for maybe weeks. But in the time frame that you'll have this flow passing over the apron, we just don't believe that, well, believe is not, we haven't calculated that that's a very likely scenario to threaten the spillway.
Okay. So maybe to summarize, like you guys, in the emergency spillway, we have several different measures that include basically additional work downstream of the secant pile wall.
Correct.
Right?
Yes.
To maybe better ensure that if the emergency spillway is ever used, that's going to better get down to the diversion pool without erosion.
Yeah, and as you mentioned, you know, the selection of the style of that treatment will likely be dependent on other things, including operations, ability to control the reservoir, and so those considerations will play into it as well.
Okay. Any other questions or comments on the emergency spillway measures? Okay, well, let's move into the FCO then.
I'd like to preface this one a little bit with what are the loading conditions and what are the vulnerabilities of the existing FCO before we start stepping through some of these measures, because I'm the deputy PM that's overseeing this work, and this is work in progress. And I think some of these measures are not necessarily the ones that you would eventually see, because some of these are very difficult to construct. But if we back up and we say, well, what are the conditions that challenge this structure? There's several, and so one of them is debris loading. We haven't seen a huge debris loading on this reservoir, but wildfire was mentioned. And then if you were to get you know, a storm, not even the PMF, but something you know, much larger than the 100-year type max events that we've seen, you could conceivably have a reservoir full of floating debris that would come into the spillways, and that debris could either jam or impact the gate structures. And so those are some of the loading conditions that we're looking at. The structure was built in the 60s, designed and built in the 60s, and it was designed and built using the standards of practice at the time. And so a couple of things have happened. Seismic loading wasn't understood and wasn't included back then to the degree that it is today. And the most recent seismic design ground input loading work has been done. It's still in progress, unless it's what it's planned for finalization early next year.
The seismic hazard analysis?
Yeah.
Yeah, it's ready to be finalized in 2020.
Okay, so
you know,
so maybe the peak ground acceleration on the structure has risen from a tenth of gravity in a horizontal loading condition up to, is it 6/10 or even greater than that?
For the 30,000, it's hovering around 0.5.
So a five-fold increase in loading. And this, I won't go into too much detail because we're now starting to get into some of these vulnerabilities that we don't want to pinpoint. But that structure's integrity was not designed with some of the features that have been included in reinforced concrete design that were developed after the San Fernando earthquake from this lateral loading. And it wasn't dam structures, but it was freeway structures that we saw. And so there's some challenges to that structure under seismic loading. And there are a couple measures in here, like adding more pre-stressing or wrapping even the piers in steel. I don't think that those really would work, but the thinking addresses the vulnerability in the structure. So we need to further think about what measures might we recommend to satisfy ourselves with the structural integrity of that gated structure. So we've got the debris loading, the seismic loading. There are anchorages in this facility that some of the stability of the gates and the foundation versus sliding under seismic loading depend on two different types of anchors. And so if one were to assume that those anchorages have weakened over time, then you would be more vulnerable to a sliding or another structural non-performance due to that anchorage. So we can assume that, and we can calculate the potential failure mode likelihood of performance. But a lot of that is based on assumptions. We don't know. You can't see those anchors. And so we're looking at what could be done to strengthen the structure.
We can't see them right now, but we know what was put in there, right?
We do.
As-built, basically.
Yeah, and so we've got information from when the FCO was demolished and replaced. Those anchors that are not the same anchors that anchor that gated structure to the foundation, but they're similar in nature. Well, many of those came out. The steel was well intact. It was not corroded, and so while you've got a vulnerability potentially if they are corroded, we haven't seen that they are. So there may be more work to do to satisfy ourselves one way or the other about the integrity of those anchors. And this is where I think it's important to remember that this is a planning study, and so we're identifying potential vulnerabilities. And so as typical in dam engineering, there may well be parts of this that we will only be able to evaluate through future studies. So the recommendations may be to consider this measure, but to get to the point that you want to implement a measure, there may be more engineering to do before we fully understand that we need to or we don't need to.
I guess the other thought on this gate structure is this gate structure design is pretty common throughout the country, and these issues that Steve's talking about here, this is something that facilities all over the country are also looking at, and are also having some of these same questions about.
Yeah, the department has tried many non-destructive testing techniques to evaluate the condition of some of these anchors with varying results, and has taken steps in their operation and maintenance of the structure to protect some of these anchors that are in place. And the IRB wrote in their report a fairly detailed recommendation on staying with state of practice and evaluation in going forward.
Matt, it
Yeah.
appears that four of the measures defer to T3BH.2. Can you kind of elaborate on that BH.2 since
Yeah.
that appears to be the one we're deferring to?
Yeah, this is the backup power for the gate operation. And there are many, Dave probably knows how many sources of power to that gate operation, but there's nothing right at the gates themselves, to my knowledge. So this measure would be to put a power source right at the location of the motors and the hoist, so that would be yet another redundancy that you would have in case you lost other means of power to the motors. And Dave, how many, aren't there at least two or three?
There's 5 ways to get power in there, but it gets it up to the control room, not
Oh, okay.
on the control, not on the deck.
Can you go, sorry, just to go back to those anchors, are those the tendon anchors that you're talking about?
Really rather not say that's the area that we're trying
Okay.
to be less specific about.
So just to, add on to what John said about, a lot of dams in the country dealing with these same issues. I know that there are a lot of dams in this country that have dealt with breakage of those tendon anchors that were built at the same time as our dam with the same, kind of anchors that have already broken.
Yes, that's a
Okay.
interest industry-wide.
Follow up on that. Is there historic pictures and inspections that actually show that all the anchors were put in properly? Because, the same geniuses that built the spillway built that, and I think the public has a right to know. Is there historic documentation to make sure there's in there? You said there's no non-destructive way to look, and it does concern me that if the gates fail, we are gonna use the emergency spillway, and my friends downstream are gonna get flooded.
There have been non-destructive tests, and they've been less than comprehensive, so what
That's an honest answer.
can be done has been done.
Is there a historic,
I haven't,
Are you talking
I've
about-
looked through a lot of the construction
was there
photos.
pictures taken or something that's,
The way
concrete?
these are, well, again, I'm gonna start to
well, I know,
identifying specifics.
I'm a general contractor.
Yeah.
They drill holes in rocks and they anchor them,
Yeah,
come on.
I don't know what records we have of the drilling and the accuracy of that.
Thank you for an honest answer.
Can I just clarify, you're talking about the anchors of the headworks itself, not the anchor rod tendons that we're talking about?
Both those types of anchors I'm trying to allude to.
Yeah,
We've done non-destructive testing on what I understand are the anchor rod tendons, right?
Correct.
And that's, maybe explain what those are. Those open the gates, right? Or they help open the gates, is that right, or?
I'm gonna look
No,
to
okay.
my
yeah,
policy level.
maybe at this point, we'll ask David
I think that'd be good to
Sarkisian
know, maybe to clarify what those things are, right? Because I'm not really sure myself.
And can I just add one more thing maybe to answer too, is when you built this structure, was there a vision of what to do when it reached its life cycle? In other words, I gotta believe when this thing was planned and built, there was a realization that it wasn't gonna last forever. Hence, was there anything built into the plans about what to do to fix it or replace it once it?
There's not a replacement scheme to my knowledge.
I could add some more, Steve. So the past couple of years, we've been implementing 3 different types of non-destructive examination for those anchorages. And each one provides different value, and it is new technology. We've partnered with some outside consultants as well as the Army Corps of Engineers to try and learn as much as we can on these features. I'd agree with Steve, in terms of the original design, there's a lot of redundancy, but not necessarily thought in the design of replacing. And so it's a huge challenge for us. And when you think of the structure and anything we do to it to improve it, with respect to the gates, we've got to maintain these concrete bays, right, for the hydraulics. There's only so much clearance between the gate members and these concrete bays. There's only so much room to try and do something structurally within a pier, within the structure, and, you know, install new steel, because there's a high likelihood we end up destroying some sort of reinforcement within there. So task 3 is really challenged to try and find solutions with the existing geometries and existing reinforcing out there. And so with the board's, you know, recommendation within the report about pursuing the technologies, partnering with others in the industry, we're doing that, and we'll continue to do that. We're basically on an annual testing program at this point with these features, and we've put in measures to protect them, even just back in the 90s. And since then, I think we've done a good job to extend their life. But also, just getting back to the redundancy, there's a lot of anchors, and that's part of the design concept, I think, was the redundancy.
These failure modes do require, whichever type of anchor, they require failure of multiple and almost a multitude of those anchors to occur to destabilize the structure.
Can
Maybe
you clarify, what is the difference? I mean, we have anchors, I'm guessing, at the bottom, and then what are anchor rod tendons? Because my understanding is the same as Genoa's, that actually other dams have replaced the anchor rod tendons. And I don't think I mean, we're not saying anything here that isn't already public. I mean, these have been in all the reports that, you know, that there's been for years, people saying, hey, you know, there's concern about the anchor rod tendons, and, you know, to date, you guys have decided not to replace them, but to continue to do testing on them. I mean, I think that's all out there. It's been in reports. And then I've kind of thought about the anchors that we were talking about originally as like the foundational anchors of the headworks gates, which to me are two different things. But maybe I'm wrong about that.
No, you're right, and I intentionally didn't differentiate. But I think it would be extremely difficult to replace just the pre-stressed tendons that are the trunnion tendons for the gates. They're in there in such a tight cluster that if one were to try to drill those and drill them out and replace them, I don't think you could do that without destroying those piers. So I think you would have to get into an overall rebuild if you were going to want to do that.
To add that, we have replaced in other facilities also, but a completely different configuration, completely different amount of space and sizing of those. So they are industry-wide, but it's apples and oranges on this particular place.
So maybe it's, I mean, would you say it's maybe a design flaw in that sense?
Well, I think what Dave said was, so what they did was they built in redundancy because of that.
Redundancy of the anchor rod tendons or redundancy on the anchors?
All above.
Okay.
But the structure itself was built with an inevitability that it didn't have a replacement model other than tearing it down, is what I'm hearing.
That's
other
right,
words,
but that's typical of a bridge or a building. There's not provisions to withdraw that reinforcing and then replace.
I guess the distinction would be bridge or a building, you don't have a lake behind it to hold the water back with no mechanism by which to release the water if that facility doesn't work. I think that's the catch in this situation.
There are things that are being considered. There was, in the IRB report, we got the comment that there was not a measure for some of this concern. And there's not there are some direct measures to try and address this. One of them I just don't think is viable, and that's drilling additional new anchors through those piers. I just don't think there's room in there to do that. But one of the measures that is included here is the employment of a new set of bulkhead gates upstream of those existing radial gates. And so while you wouldn't with that prevent the loss of one of those gates, the likelihood of the progression of losing a gate through the successive failure of multiple anchors may be low enough that you might be satisfied with the provision of putting in new bulkhead gates, so that if you did happen to lose or damage one, you could drop those bulkhead gates and cut off the flow through that structure. That's number
3A.
3A. And so again, we're not finished with this one. We have to work on these measures to satisfy the concerns of those different loading conditions.
Have you, as a department, looked at a scenario and, maybe you can't, I don't know, like what happened at Folsom with the gate failing? What would you guys do if a situation like that happened here? I think that's what we're really talking about. Are you looking at that? Because what I'm hearing is there's not a really easy fix. So what happens if something does happen? How do you address it?
We are looking at that, and those scenarios have been described and looked at and looked at again. And if you remember, in the beginnings of this risk assessment, we said not only were we going to look at ultimate failure, we were going to look at, does the structure perform as intended after it's damaged? And that's one of the difficulties we have with that is it satisfactory to have a damaged gate bulkheaded off and then allow yourself the time to come in when reservoir conditions permit to make the repairs like was done at Folsom? Or do you want to circumvent that entire potential?
So I'm hearing that, there's no way to replace these pieces, really.
I didn't say no way.
without further damaging things, and things are really tight there, and there was no plan to replace things when it was built. Have you considered rebuilding it? Has that been a consideration?
I think you can say, seismic remediation. I mean, that's a place to start with many components in a dam. And so if we say that, then what does that mean? And we have to think about that. And because obviously if you were to do a major retrofit on that structure, you've got to take it out of service for some time. So how do you manage the facility during that interim in consideration of flood control maintenance? As soon as you disable the capacity in that spillway, you've lost a lot of control to maintain that release at 150,000.
One thing we did talk about earlier today is the potential on the emergency spillways is build a new flood control outlet. It basically would be redundant to the first one. And basically that's a total replacement. And then, so you would.
But if you do that, then you almost have to build another spillway, right?
So what would one scenario would be is that you would build a second one that's capable of 450,000 CFS, that between the two of them could handle the PMF with nothing going down the emergency spillway. And with the new one, that would take the place of the current one for most routine operations, and you would only use the existing one for rare events. And even then, you would probably do some of the, or at least consider doing some of these potential measures to upgrade its structural capacity and the reliability of its gates. So answer to your question is, yeah, we have looked at that. There is on the table a measure for a second brand new FCO.
Okay.
So that's, one of the measures would be a brand new FCO, right? But what is not a measure is deconstructing and reconstructing the existing.
But you could, then if you did, if you did put in a second FCO, then that gives you more flexibility to take that
To do
partially
that.
out of service and work on it at a pretty low risk.
Right, because the problem is if you're not gonna be able to do that within, it's probably gonna take at least 2 years, 3 years
Longer.
to redo a whole gate.
Well, once you get into construction, no, I think that, well, yeah, probably the construction period is a 2-year duration.
And in the meantime, you don't have gates that are really the primary way of managing flood flows.
Unless you were to sequence it so that you put the new gates in and then you went to work at repairing the existing after you had the new ones.
It just doesn't make sense to me to have this brand-new state-of-the-art spillway with these old, cracked, decaying gates on top of it.
Yeah, and maybe,
But
I'll just-
I mean, to be fair, I think what they're saying is, hey, there are things there that need to be looked at, but I don't think they're saying that it's like failing right now, or.
yeah, I would like to maybe just elaborate a little bit more. So through this process, we're evaluating, what enhancements to make. But over the years, after Folsom, we did go through an effort to reinforce the structure. Dave mentioned we did implement measures to protect the tendons. After the small percentage had an issue around 20 years ago, and that's been successful. So we've been proactive, and now this is the next step as the facility is getting older to.
Does anyone have the current measurement of the diagonal crack on Bay 8?
Yes.
Yeah, we had
Can you
structural,
share?
we had structural engineers look at that, up close personal man lift and everything. They gave us an assessment that it was not a structural issue, and since then, we've sealed it. And so that's something that's, on our docket, so to speak, on our inspections, even though it's been sealed.
Which was another thing that's been public, it's been in the inspection reports, right? And I
Yeah.
think what we're just saying is like, hey, these are all things that people know about, right? And what's the plan for dealing with those, right? And you guys do have a plan for dealing with those, that's what I'm hearing. But there's a lot of uncertainty, is that the best way to say it? I mean, there's a lot of uncertainty in terms of,
So as
Right.
far as being maintained, inspection, excuse me, as far as being maintained, inspection, and continuing operating and testing, the gates are in good shape. Now, they were designed years ago with different seismic standards. There's some other things that you can't get to, and those are the things that are being evaluated, the risk and how to go about addressing it. But we have no known deficiencies on those gates right now. They're in good shape, including the structural gets examined every year and looked at, all the metal structure and all the gates and all that.
but there are things that we just don't know, right? We don't know for sure about the anchors, like is there corrosion there or not, right? We just don't know that because we can't get there. But we have some evidence to suggest that they're not, because the ones that we did pull out nearby had no corrosion.
Right.
That's good, right? And then we know the anchor tendons have failed at other places. They haven't failed at Oroville, right? But
Yeah, and
there's at least a concern there.
yeah,
right?
no, we have, first of all, there is no such thing as zero risk. We all know that.
Right.
And we're looking at all the risk, and if you look at this, I think, I hope you guys see that there are measures being considered to say, what is the best combination of things to look forward in a feasibility study to go forward. In the meantime, we're trying to address everything that we can possibly in the maintenance and inspections to ensure that they stay reliable. So I think between the comprehensive needs assessment, that's a very good balance of long-term risk and looking at what we can do to ensure the long-term reliability of that. While today, we're ensuring the current reliability of what's known and what can be addressed today. At least that's what we're trying to.
And so some of those things that we've looked at, right, are, these things identified here, right?
Right.
One is replacement of motor, wire, rope, hoist machinery, connections, coupling, and high-speed gearbox with modern equipment.
Yes.
Right.
And we've already, over the last 2 years, gone through and had a series of refurbishment on that. This would be what's left on that.
Okay.
But they're in,
But that's the actual equipment that actually opens the gates, right?
and, correct.
And then you're looking at, let me see here,
The bulkheads, T3A, the first one, putting
the
the bulkheads.
emergency bulkheads would be, hey, if these things fail, we have a backup, right? If something happens to one of the gates, the bulkhead is gonna help meter out water.
Yeah, it would
Right,
close off the gate so we don't have an uncontrolled.
So we don't have an
release like at
uncontrolled
Folsom.
flow situation, okay?
Mitigating the Folsom-like event.
You have something in front of the gate.
So if the gate blew out for some reason, you have another gate in front of it. If one of the existing gates blew out for whatever reason, if you have these slide gates in front of it, then you would close that particular bay. They don't currently have that capacity. There's not a set of bulkhead gates right now that are there. This is an alternative that would mitigate that to be considered.
During a flow event.
Right.
During the flood.
We can't cut it off if the gate's already closed and do work on it, if we do. We have stop logs. We currently have stop logs in front. So if we want to do maintenance in the dry and everything, we can lower down those stop logs and open and close and test and go in and inspect and everything. Those can't be put in under flow, though. So if you had a Folsom event, one of the proposed things is to put slide gates that can go under flow.
Right. And the other thing, if we block that off and we're in an event where we have rising elevation, though, we essentially have blocked off those gates and we're gonna have to rely on emergency spillway, right?
Potentially, but that would be an unseen amount of flow over this first 50 years.
Would those slides be per gate? Like there would be a bulkhead slide for each gate? So you could block off one gate and still have the other 7 operating?
Yeah, and there are other hydraulic issues of now if you take anyone out, you've got to balance the flow so you don't get weird hydraulics in there. But yeah, we think it could be operated.
So that's kind of an intervention type measure, right? But then you also have, if required based on a study, design and construct anchorage to secure the spillway terminal structure to the bedrock foundation.
Yeah, and so this you would.
That would be going to the anchor issue, right?
Correct. And we do
so
have
that's
photos of that, and there were lots of them in good rock, and I don't think that there's any reason to think that those are deteriorated, or because, again, for that sliding, this failure mode was that you're going to get seismic loading against the gates at full reservoir, and with the inertia of that structure, these anchors are going to pop and you're going to move the whole structure downstream. I think that likelihood of that happening is very, very low.
Okay. And again, yeah, our best evidence says that the anchors are fine. Right. But then you have install longer anchors into existing headwork structure to increase stability. Is that, we're going to look forward, it's carried forward, right?
For consideration, yes.
But that was where you were saying, I don't know if there's enough room to do that. In your opinion.
There were two types. One was to anchor the structure to the foundation. Another was to create a greater stress field to increase the rigidity of the reinforced concrete structure. So there were two different types of anchors proposed.
When Steve said he didn't think there was room, that was the other type of anchor. These are the ones where there would conceivably be room for extra anchors.
So that's another possible measure.
I think we have to find some other, you could add more anchors to the foundation. Adding more anchors through the piers, I don't think is likely.
And then here towards the end, you have add PT or passive anchors, steel wrap FCO piers, add pier struts.
These are measures, all that would be required to compensate for the increased seismic loading and the differences in how you design for shear in reinforced concrete today.
So those are additional measures we could look at that might help.
I think those
That would
are-
help against a seismic event more? Or-
There's one in there that's seismic bracing, and I think that one is possible. Actually wrapping those piers in steel, I don't think is viable.
And this is in what we were saying, how large of a seismic event?
It's a 30,000 year event.
1 in a 30,000 year event. The only reason I bring that up is, it's not that we're not considering, because it's the new design standard, but the likelihood is a ways out there.
Is the concern both, I mean, seismic has been talked about a lot, right? That, hey, if we have a seismic type event, it could undermine the headworks. And like I said, it's a remote type of event.
And
Right.
we've already experienced one up there.
But is the consideration also, because I feel like we're also hearing aging is also another consideration, like just that, like it is with every piece of infrastructure, right?
Right, right.
So that goes to kind of what I'm thinking is the department looking at this concept of is it worth doing some of these measures to retrofit it for seismic stability to modern standards versus perhaps a model where you build another FCO.
So when you look-
and then tear this one down and build a new one in its stead.
So you're looking at the measures, the possible measures that could go forward. Those are future steps of what they're going to do is, okay, what combination or what's the right approach to address these?
That's where we're hoping to
different-
end up, right?
Right, right.
Is something that maybe, what is the combination of measures that
Right.
maybe is the best?
And there could be several combinations addressing, different amounts. But yeah, that's what's next. You're looking at the measures that are more of one measure can address multiple risks, but they were done more in a discrete method. Now, start looking at the combinations that are on the page and where to go from there.
Is it sounding like, and I know we're not done yet, but is it sounding like maybe the best long-term plan for this is to actually build a new FCO gate? And there's also in the plans, potentially we do another spillway adjacent to the existing spillway, and then you end up with a brand-new FCO gate, and the old one is, at least you'd have the ability to maybe try to do some things to it, or just use it sparingly.
Right, so that's part of the process that we have underway, is to add those into different plans, and one plan might have a new FCO spillway and new slide gates for the existing FCO. Another one might have a lot more reinforcement for the existing. So each plan will consider a different set of measures. A couple things I did want to stress is that we've talked about a lot of different potential vulnerabilities on the FCO, from the concrete structures to various gate issues. One of the gate issues lies in the pink, but the rest of the issues are not in the red or the pink at all. They're in the amber or below. So strictly speaking, they don't cry out to be addressed because they don't meet they are basically meeting tolerable risk. But despite that, we're going to carry them forward and take a look at them. With regard to seismic, yes, Oroville is in a seismic area, did have a sizable earthquake in 1975, magnitude 6. But compared to other places in California and other dams, it is a low seismic area. We're talking about the level of earthquake that would cause severe damage is on the order of 30,000 a year. Much stronger earthquakes, magnitude 8s, within a mile, lie at many dams in Southern California and in the Bay Area with return periods of 100 years. And so you have to take that into account when you're thinking about, earthquake and seismic. There's a relative, risk and relative likelihood here.
Yeah, I mean, the only thing is that in that 1975 event, these materials were 10 or 15 years old. Now they're 60 years old, which is 10 years past their, expected useful life. So it gets a little scarier.
Well, many of these features, and I'll start with the embankments, are expected to just get better with time. Some of the concrete gets stronger with time. And as long as the steel doesn't seriously deteriorate, it probably is as good as it was when it was first installed. So it's whether or not it's deteriorated or corroded. When we do these potential failure modes, in terms of looking at likelihood, we do consider what are the indications of any corrosion or deterioration or cracking. That is, a consideration when we look at likelihood. Similarly, we look at how old is the design or how antiquated is the design. These are 50-year-old designs. Some of them still meet modern standards, some of them don't. And then that's a consideration in looking at the likelihood.
So that takes us through talking about the two spillways here, in which we can continue to ask questions or talk. That's kind of the bulk of what we were. We do have some time left here. Do we want to look at? And I'd propose maybe the embankment ones, and I think the reason I'd propose that is the embankment. Those were some of the ones that would tend to be more in the gray. Correct me if I'm wrong there, as opposed to the low-level outlet items were more ones that were in the green, different green shades. So, but at the same time, I think I'd actually, instead of saying that, I'll take requests from the crowd here. If you guys, which one you would prefer to focus on?
I don't know, is there ones that you guys want to particularly maybe spend a little time on? My first blush on the embankments is, like I've said, I think it's the first time I've heard that we really need to raise embankments. And I'm just kind of, I don't know, my first blush is I'm kind of skeptical that that's
I don't
something,
You're saying we need to?
It's considered.
It's considered because if you go beyond the potential maximum flood.
Right.
Or probable maximum flood, excuse me.
And so I think maybe more, to me, maybe low-level outlet is something that's a more like real.
I gotta agree. I mean, we're here, to give our input for the citizens, and I think a low-level outlet is probably necessary. Climate change is real. Warm rain on snow, potential for 200% of snowpack has almost been reached, and then we had warm rain. The maximum, as you point out over and over again, maximum flows have never been really tested in this facility, but I don't think you have capacity between 813 and 900. And if we have 200% of snow on an ongoing Pineapple Express, and then I'm sorry I bring it up, but I just believe that we can't trust that the gates that are there were built properly. I mean, until you said there's no way without destruction, unless you've seen pictures of everything anchored in the rock, and I feel good on your word on that. When they built that structure, that we need that redundancy to maybe in the future, maybe it's good for another 50 years, but if you have the low outlet, it's gonna help us with our operations, and it's also gonna give you the opportunity to repair stuff. I think from the public safety, it's just leaping out at me. I know this is just consideration of all of this at this time, and I'm sure money will play a part in it. Or maybe you could dig a tunnel and have a drain at the bottom of the lake. I mean, something to give yourself capacity. And I hope that we understand that we're going to explore how water is shed in the entire basin in the future. We're going to use modern technology, a lot more understanding of how the entire watershed operates. And behind that, there is the possibility of failure of upstream dams, which nobody's mentioned here today, but there is a potential of these aging dams, they're losing capacity all up the Feather River Canyon. Who knows what could happen if there's a huge local rain event there, it might bring water to us, but I'm sorry, but that's on my mind.
No, I think that's,
why I'm here, I guess.
Well, let's
I think
spend,
those are all, good perspectives and, so maybe if we go into low-level outlet.
sounds like
a little bit,
low-level
talk
outlet is the
about-
way to talk about there.
On our list, we have, for table 3, we have a series of potential low-level outlets, and I'll start with the first one that we carried forward. I think it's T4-C. It's a low-level outlet actually, it's not very low level. It's at elevation 775 with a capacity of 60,000 CFS. And what that is intended to do is that the Division of Safety Dams has a guideline for emergency drawdown. They actually have two guidelines. One is to draw down 10% of the reservoir within 7 days. And so 10% of the reservoir is about 57 feet. And so the FCO can do that in 2 days because it has, capacity all the way up to 300,000 CFS. We figure what if the FCO gates were damaged? So if you had an earthquake and you couldn't open the gates, what would provide redundancy to meet that criteria, to draw down 57 feet in 7 days? You need some type of outlet that would produce 60,000 CFS. So that could be a tunnel at the upper end with an intake at 775, or that produce 60,000, or it could be a tunnel that's 40,000 that's used with another lower level outlet in combination. So that's what that option is that's been carried forward.
You say tunnel, can you explain what do you mean tunnel? Like a tunnel that would run, how would that work?
This would be a tunnel, and so we're looking at tunnels on the order of 20 to 25 feet in diameter. You know that from the original construction, the diversion tunnels there, they were 35 feet in diameter, and they run about 4,000 feet long. They connect upstream of the dam to the reservoir, go through the left abutment and discharge. They've been plugged off, but the Hyatt power plant discharges them now. So we're looking at tunnel sizes of on the order of 20 to 35 feet in diameter, that they would be bored through the rock, and we look at different alignments. There's potential alignments to the right abutment, underneath the FCO, or through the left abutment, trying to miss the power plant. They would be drilled, and then they'd be concrete lined. They look like the diversion tunnels that are in place. They would have energy dissipating valves at the downstream side by the river, so that they dissipate the energy as it's discharged into the diversion pool. They would also have gate structures to control opening and closing. So we're looking at various sizes, various elevations. The one I was just talking about is probably a couple of tunnels at elevation 775 that would be able to meet the discharge requirement for the upper 10% of the reservoir. It would be a partial redundancy to the FCO, not a full redundancy, just enough to meet the drawdown criteria that dam safety feels is an appropriate level. Any other questions on that? I'll move to that next one. That was C, T4-D. This is a low-level outlet at 610. 610 was picked because it gives full redundancy to not only the upper 10% we just talked about, but also it provides a redundancy for Hyatt. So Hyatt can take down to about 650. So by picking a 610, we give full redundancy to Hyatt. We also, if you're able to draw it down to that, if there's any damage to the intakes at Hyatt, you can do a repair. You can pull the reservoir down to that. So that option was picked as one of the things to carry forward. And the 20,000 CFS capacity there, that's generally to meet the safety dam's second guideline, which is to be able to dewater the reservoir completely to some level within 6 months. This doesn't take it, this takes it halfway down, but it follows the rate that, in terms of number of feet per day that safety dams requires. Elevation 550, that was picked because it has, several things about that to consider. One is that our operations people have said that if, we asked them what level would give you additional benefit for operations, in part for temperature control for releasing the reservoir. Because right now during droughts and when the reservoir approaches the limit for the Hyatt intake, they have to rely on the river valve outlet to meet the cold water requirements. So we asked them what levels would give you benefits, and they said being able to go down to 550 would give us a significant benefit, probably not much more beyond that. So for an operational point of view, 550 provides benefit. It does provide full redundancy of the Hyatt deliveries. And then the other thing about that to consider is that in terms of internal erosion impacts on the main core, below 550, you don't get any benefit because water gets trapped between the cofferdam core, which is the top of that is elevation 550, and the main dam core. So what happens is even though the reservoir is down, the main dam core still feels that trapped water. So you don't get much benefit from going much beyond below 550. That was...
Would any of these have additional electrical, would you design this to generate more electricity out of these low-level outlets, or would this be simply to get water out of the facility?
That would be something that could be considered for the future. Right now, we're considering it as basically a redundancy to the existing facilities. You wouldn't normally use that. That's not to say it couldn't be looked at in the future.
In simple terms, what is the risk we're trying to reduce with these scenarios?
One of the risks that you're trying to reduce, or set of risks, is if for some reason Hyatt power plant becomes unusable. So you're able to make deliveries bypassing Hyatt. So if Hyatt is unusable, if the power plant is damaged in some way, and they can't make water deliveries, they can not only just fail to produce power, they can't make water deliveries either. So they mainly they would have to rely on secondary systems. This provides redundancy for that. It also, as I said, if you put it up high with a high enough capacity, it provides partial redundancy for the FCO. As these go down in elevation, as I said earlier, I think we all know, you can't ever, right now, dewater reservoir more than halfway down to elevation 650. The lower you put the reservoir, the more you can dewater it, if you had to or wanted to. So some of these that go down to 610, 550, and 335 provide the ability to, 335 provides almost full dewatering of the reservoir.
Wouldn't that allow repairs in the future? I mean, we're talking maybe 100 years out, that you would have a way to do major repairs or modified operations.
That is exactly one of the considerations, like when I said about 610, one of the things it does not only provide full redundancy at the Hyatt, but takes it below that elevation 640 lip where the intake is, so that you can bring it down there and hold it there while you do repairs.
Right.
All right. So,
Makes sense.
But it doesn't do it very quickly, right? I mean,
No.
the lower you go,
It's better
the
than never.
your capacity is limited, right?
right.
Well, at least from these measures, it seems like the lower you go, it's, 20K, 10, 15K CFS, right?
Right.
Whereas if we're saying, hey, we see like a big storm coming, we want to get this thing lower, you want something with more CFS, right?
The board did make a recommendation to, don't just think about an upper or a lower, but think about maybe a
I was gonna bring that up,
combination of
right.
the two, yeah.
And is that something you guys are gonna look into, is?
Yes.
Yeah, I mean, to the board, you guys had recommended that, hey, rather than doing two different outlets, maybe you could do one that would do redundancy to both Hyatt and the FCO, right?
Bet they'd look at such a measure in addition to the other options they were considering.
And that would maybe theoretically be a higher capacity outlet?
It would have to be in order to meet both criteria that Dr. Harder mentioned.
Like bigger than
The
60?
The concern with,
It would be 60.
60?
I'm sorry,
He was asking what the capacity was. It would have to be, it'd be 60.
yeah, it'd have to be high, which means you have to allow very high velocities through that outlet, which, poses some concern. So we're not recommending it, we are asking that it be
Looked at.
and considered. Yeah. Possibly for short durations, you could allow that to happen, but you wouldn't want very high velocities through a tunnel like that for long durations.
I guess what I heard on the, what risk are we trying to reduce? I heard, backup for Hyatt or, and redundancy. But I don't know if I really heard the same risk that Supervisor Connolly and my boss talk about, which is the, getting below the 813. I mean, is that part of the motivation here?
Well, just as a review, the FCO can take water down to 813. After that, you're relying primarily on the Hyatt power plant to take it down to 650. Beyond that, you really can't take it down with the existing facilities. You have the river valve outlet, but it has such a low capacity, it only basically meets what flows into the river, into the reservoir on a yearly basis. So what this would do is that it provides redundancy to Hyatt. It provides partial redundancy to the FCO under one of these measures, so that you could do the upper part of the reservoir. And in addition to that, you have then, depending on which elevation you pick, you have greater ability to dewater the reservoir should you want to make some repairs at a particular elevation.
What about lower the reservoir in order to increase the flood buffer?
I think that would be where this 775 one probably best does that.
But is
Right.
that, I mean, is that what?
Well, remember what the flood buffer currently is. The current flood buffer is roughly, for most years, around elevation 848. So that's easily met with the existing FCO right now. And even if you wanted to lower that flood buffer 40 feet, you could still use the existing FCO to do that.
So the motivation behind considering building a low-level outlet is not in order to dewater the facility in advance of a huge warm rain on snow event?
It sure could help.
But that's not the primary reason why we're looking
Well,
at this.
we haven't earmarked that yet, but I think it absolutely would be in the, operational considerations. The more, increased operational flexibility is desirable for a lot of things.
I read it, I mean, Les, tell me if I'm wrong, I read it as the T4C is the one that it's at 775 feet, so below the existing FCO, and it's 60K.
Yep.
That particular option is providing redundancy to FCO and Hyatt, right?
It provides, the short answer is yes. It provides a partial redundancy to the FCO in that 60 out versus 150 to 300K. It does take it lower than the FCO because the FCO is 813 and then this proposal is 775. So it does provide an additional enhancement of that. But at 20,000, it's not much more than Hyatt. But they could be used in tandem as well.
At 60,000, right?
Well, I was looking at the 20,000 beyond, below that.
As far as,
And then the other ones, the lower ones though, the D, E, and F are more about, they kind of just provide redundancy to Hyatt.
in case of,
Go ahead.
Just between the two elevations, in the case when we had the 5 years of drought, we were operating below 775 a lot and relying, going all the way down to Hyatt. Matter of fact, we were close to going below Hyatt's capability and only operating on the river outlet. So there's those operational considerations versus the increased capacity that you're talking about. And those all have pluses and minuses. Is that?
Right. Yeah, I mean, but I don't know. I feel like the safety element of things is really more present, not during drought.
It would also, though,
It's
depend
more-
on what combination of other things you would consider.
Right. But I mean, I think a lot of the concern from our communities has been, hey, is there a greater ability to help dewater the dam when we need to? When we really, especially if we're seeing forecasting that shows we could have a huge influx of water, so that we don't get to that point where we're like, oh my God, we got to pull the FCO and go to 150, 160. You know, maybe we can get more water out.
So at Folsom.
Earlier in
you guys
time.
can correct me, at Folsom, they did another gated spillway at a lower level.
Right.
Just for that. So there's different ways of accomplishing that. I agree.
Right. Well, would these scenarios do the same thing or no?
I would just add, and I'll look for Dave and Steve to join in, but I think when they start working through the plans at our next meeting, we'll be able to get into that a little bit more. But Steve, maybe you can comment now.
Well, I think there's several, you know, in talking about a lower level than 775, it would give you a discharge that's not dependent on going through the turbines, which is desirable, because you can only operate that if you've got power to load the system. And so if the power goes down, you can't release, and you'd like to be able to do that. In another argument for a low-level outlet on any dam is one of the things that often happens if you get seismic damage of any type, then you want to start drawing the reservoir down. And so to have something, again, through non-spinning equipment would be good capability after a seismic event. And then this is getting out of my field, but it seems to me that in the when you start looking at the long-term or the flood forecasting operations, the ability to release and create space would also be enhanced by this outlet.
By which one?
Either, but you know, I think we're thinking about an option that is intermediate between that large capacity high level and the smaller capacity lowest levels.
One of the benefits too of, you know, the lower level outlet, even if it is smaller capacity, is if there's some kind of embankment emergency. If something shifts and they need to start, you know, getting things down, it's below the gates, and Hyatt's only half working, getting water out of there is important. I mean, I know, I read the green spot study. I mean, it is you know, that area gets really wet, and if there was some kind of seismic activity and it shifted because it's so saturated, they'd want to start, you know, releasing water as fast as they could, even if it was lower than the gates. So, again, one in however many million or.
Right.
What is the technology to do this? I mean, is this something that is, I mean, in my mind, building another low-level outlet at any level is going to be a very complicated engineering feat, right, in an existing facility? Is this something that kind of been contemplated at the infancy of the technology, or is it something you guys could do relatively easy
In
in
between.
terms of realities?
I'd say the answer is in between those extremes you mentioned. It's definitely not a routine. It's rarely been done. One of the things that we're talking about doing for any reservoir tap or any tunnel intake that's going to be much above 700 or any below 700, you're looking at a hot tap into the reservoir under pressure. Well, that's pretty dicey just to even think about. Has that been done? Yeah, they did it on Lake Mead. What kind of depths have they done? To 300 feet. So it has been done before, but there is risk and construction risks. One of the things when we evaluate these alternatives or measures in the alternative plans we're going to look at is construction risk. Because the deeper you go, the higher the risk is going to be that you lose it during construction and you have some type of terrible thing then. And so going deeper has negatives as well, not just cost, but there's a construction risk associated with that. Has it been done? Yes, but rarely.
And in California, there's two projects actively pursuing this now, one for the city of Santa Cruz and one with Santa Clara Valley Water District. They're taking new bores through, just happens to be the right abutment for both of those dams. And it's a much smaller scale, but it's the same operation, same construction risk.
I volunteer Rob to be there when they tap it.
I was gonna say you, Bill.
No way. No way.
So we're coming up on our 11 o'clock time period here. So don't want to cut short good discussion, but just want to make sure we're all aware of where we are time-wise.
So as a summary, we're looking at all of these measures as potential low-level outlet, as a new potential low-level outlet on the dam. Different elevations, different capacities, and then we're also going to be looking into what the IRB has suggested.
Mm-hmm. And then looking at those in conjunction with work you could do at the emergency spillway, work you could do elsewhere.
Right. Okay.
And so this meeting, I mean, this was, condition assessment, measures, and so what we'd see, we've got 2 more meetings on the books here talking about the study as it's going. So the next one would be, we expect to see these plans coming together, and we'd have a discussion then about the combinations of measures. Is what we would propose that we talk about. And then that one is
And then maybe we could spend a little bit of time on Hyatt and embankment stuff if you want to cover that next time, or?
Yeah, I mean, to some extent, I think we covered a lot of it, so we can
Right.
about if there's anything else there. But I think the major points here we've covered. So I think we'd propose just to jump right into the plans.
Into the plans and how they're connecting,
Yeah.
how the measures are going to maybe cross-connect.
Next meeting's in what,
March 20th?
So that's like 4 months, so there'll be substantial work done between now and then on all this. Okay.
Yeah.
Okay.
Actually, John, I gave you wrong dates.
Okay.
Those dates are when we're meeting with the IRB.
I will share with Rob and Curtis the correct dates that we will circulate with the
So
group.
probably sometime in April, you would suspect?
Be after,
Yeah.
yeah.
Probably three weeks or so following the IRB meeting.
Okay.
So I just have a question for some information, maybe. You had mentioned maybe getting like a list of the PMFs, if that's too much information for us to have. Could we,
I don't think we said a list, and law enforcement would not agree with that, and I would not. I think we said we could characterize.
yeah, that was too
Something
much
different.
information, right, with the list. But if we could maybe have a characterization of where they fit in with these, like of these 21 that are in amber, how many are in the embankment category, how many are in,
Yeah, I think we can do that, that kind of characterization.
yeah, that would be great.
I mean, I'd like to give us as much information as you can.
Yep.
Right.
That's what we're.
But what I was trying to think about is like, okay, I know you said, hey, 4 up here in the red, obviously those are the priority. But to me, amber is important too, because it's in that,
Sure.
zone. Even gray, very remote, right? The potential
Yep.
catastrophe, well, I mean, what are kind of the things we're looking at there?
Yeah, it'd be nice to know, like, things like, I think one of the ones in red was had to do with the gates or the FCO. And so, yeah, if you could see where the dangerous things are.
One of the reds was a seismic event, the 30,000 seismic event affecting the headworks, right?
Yeah.
Another one was the erosion back to the secant wall on the emergency spillway, or is that right?
No, the other one had to do with erosion downstream.
Downstream of the secant wall, right?
The other one you mentioned about the earthquake in the FCO was actually at the junction between the FCO monoliths and the embankment, leading to erosion at that point.
Right.
So it becomes an issue that starts at that junction, but becomes a failure of the main embankment.
So yeah, I mean, if we can get like just kind of a characterization of those different PFMs that are in what are the PFMs in those zones? Right, as best as we, right.
Absolutely.
But David, don't you think we could see for each of these zones, we can say, well, there's 18 or 21 in the amber, for instance, and say, all right, of the 21, 3 of them were with the FCO and 4 of them were with the embankment and so on. And so you say what facility those are, and then you can say at a high level, well, for the embankment, it's either overtopping or internal erosion. For the FCO, it's a structural problem or a gate problem or something like that. That's the kind of thing you're looking for.
Yeah, that would be helpful, I think.
I don't know if it was said, but the measures look for measures. I was gonna ask you to let you, but, the PFMs in the pink and the amber were all looked for measures to address all those, move forward. And in the light greens, many of those.
We all,
So-
because,
That's important, I think.
well, I agree, it is important. So strictly speaking, from a tolerable risk point of view, there's only 4 PFMs, those that were in the light red, lower red, that really call to be mitigated. The IRB asked us to say, considering the uncertainties involved with estimating in PFMs, please, consider uncertainty in developing measures. So what we did is we didn't stop at those 4. We looked at all the ones in the amber, some of the ones in the gray, and some of the ones in the upper green to develop measures for. And we looked at those, and we developed measures for all of those. Some of them we dropped because they wouldn't either do much, or the risk was really, really low. So even though some plot in the amber, they plot there only because our chart only goes down to less than 1 chance in 10 million. Well, actually, some of these are in the 1 in a billion chance, and so they're strictly not in the amber, but from a mechanical plotting point of view, they're there because our chart doesn't go any less than that. So that's part of our considerations as well as we go forward.
Okay. Well, I would just end by saying, look, I think everybody here feels like there's been a lot of good work done here, and I want to emphasize that. I know that there's been a lot going into this, looking through a lot of these different scenarios, PFM analysis. So we really appreciate that. And obviously, we're going to be skeptical because that's what we're supposed to do, and we're going to ask questions because there's a lot of stuff that we don't fully understand, but, we want to better understand everything that's going into this, then we can help communicate that to the public, but it doesn't underscore that, hey, I think we're moving in a really good direction, and there's a lot of measures here that I think are really, really promising to helping make this, the dam, a much safer facility in the long run. So, which is what we're all here for. So, yeah.
Thank you very much. Thank you all.
Thank you, guys.